Good morning dear friends, myself Dr. CS here. So last video we complete this relation between ionization constant and ionic product of water. This relation is this Kw, that is ionic product of water, is equal to Ka into Kb, that is ionization constant of acid into ionization constant of base. So today we start this new topic, that is pH scale. In 1909, this E.S.P. Sorensen was introduced pH scale. Pure water is neutral. When we added chemical substance in water, the solution become either acidic or basic. The pH scale measure the acidic or basic nature of substance in aqueous solution. The Sorensen definition: the pH of solution is the negative logarithm to the base 10 of molar concentration of hydrogen ion present in solution. Mathematically, same definition is this pH is equal to minus log of H plus ion concentration. This square bracket represent concentration, hydrogen ion concentration. And we know this hydrogen ion concentration in water is, that is the hydronium ion H3O plus. So it is equal to minus log of concentration of H3O plus. Thus, pH is used to indicate the hydrogen ion concentration. The pH of 1 molar strong acid, for example HCl, is 0. How? This pH is equal to minus log of concentration of H plus ion. If it is strong acid, this H plus ion concentration is same, that is 1 moles per liter or 1 molar. So we put this value 1 here. So minus log of 1 is 0. Whereas when 1 molar strong acid, strong base, for example NaOH, the OH minus concentration is 1. OH minus concentration is 1 molar. And we know this pH is equal to 14. How this pH is equal to 14? See here. We just now complete this ionic product of water. Kw is equal to H plus ion concentration into OH minus ion concentration, and this value is 1 into 10 raised to minus 14 moles per liter. So this H plus ion concentration, see, when you put this OH minus ion concentration as 1, so this H plus ion concentration is same as that of Kw. So this H plus ion concentration is the value of Kw, that is 1 into 10 raised to minus 14 moles per liter. And thus this pH is equal to minus log of H plus ion concentration. So put this value H plus ion concentration as this minus log of 1 into 10 raised to minus 14. When we take this logarithm, at that time this minus 14 into minus, that become plus 14, and this log of 10 is equal to 1. So this value is 14, and thus for strong base this value is 14, and thus acid pH value is 0, for base pH value is 14. So this is the pH range from acidic to basic solution. Therefore this pH scale ranges from 0 to 14, that is acid to basic condition. A pH of pH 7, we know that pH 7 is a neutral pH, neutral solution. A pH less than 7, that is toward to 0, it is acidic solution, and pH greater than 7, that is a basic solution. Similarly, pOH of a solution indicate the hydroxyl ion concentration. It is defined as negative logarithm to the base 10 of molar concentration of hydroxyl ion present in solution. So instead of pH, we have the OH minus concentration. So this pOH is equal to minus log of OH minus ion concentration. Square bracket represent concentration. Thus this pOH is used to indicate the hydroxyl ion concentration. The ionic product of water Kw is expressed in logarithmic form as pKw is equal to minus log of Kw. But we know this Kw is equal to mole concentration of H plus ion into concentration of OH minus ion, that is the ionic product of water. We put this value, so instead of Kw we put this H plus ion concentration into OH minus ion concentration. We separate these two term, minus log of H plus ion plus minus log of OH minus ion, and we know this minus log of H plus ion is pH, plus minus log of OH minus ion is pOH. So this pKw is equal to pH plus pOH. Again, as we know, Kw is equal to 1 into 10 to the minus 14. Then pKw is equal to minus log of 1 into 10 to the minus 14. And this value just now we calculate, this log is 14. So this pKw is value is 14. And therefore this pKw is equal to pH plus pOH and is equal to 14 at 25 degree centigrade temperature. And thus we know this pH plus pOH value is 14 and is equal to its pKw. So this is important at 25 degree centigrade temperature. The sum of pH and pOH is equal to 14 for water or aqueous solution at 25 degree centigrade temperature. Similarly, ionization constant of weak acid and base are expressed as pK, that is minus log of K, pKb, that is minus log of Kb. So we consider some problem based on that theoretical explanation. First problem, calculate the pH and pOH of 0.001 molar solution. So this concentration is given, that is 0.001 molar. Since so this is concentration of HCl solution. So since HCl is a strong acid, it is completely ionized, and hence this H plus ion concentration, see, this H plus ion concentration is same as that of the acid concentration. So here this HCl is missing. This is the HCl solution. So this HCl concentration is due to the strong nature of HCl. This HCl concentration is the concentration of H plus ion. And this HCl is strong acid, completely ionized, and hence concentration of HCl is the same as that of a concentration of H plus ion. So we have that concentration of H plus ion, then we easily calculate pH. What is pH? pH is equal to minus log of H plus ion concentration. Put these values of H plus ion concentration, taking log. So 0.001 is equal to, is same as that of 10 to the minus 3. So minus 3 into minus plus 3, log 10 is equal to 1. So this value is plus 3. So pH of HCl solution. So this is a HCl solution. This pH of this HCl solution is 3. As we know, pH plus pOH is equal to 14. So this pOH is equal to 14 minus pH. 14 minus pH. pH is 3. So 14 minus 3, it is equal to 11. So pOH of this HCl solution. So this pH of this HCl solution is 11, and pH of this HCl solution is 3, and pOH of this HCl solution is 11. So this is the problem. Next problem, calculate the hydrogen ion concentration of a solution whose pOH is given 8.6. So hydrogen ion concentration is to be asked. So we know that pH plus pOH is equal to 14. pOH value is given. So this pH is equal to 14 minus pOH. So 14 minus pOH is 8.6. 14 minus 8.6, 5.4. So we know pH is equal to minus log of H plus ion concentration. When we consider this, when we shift log this negative term in this direction, so this log of H plus ion is equal to minus pH. So this pH value is 5.4. So it minus pH, we put the value pH minus 5.4. Therefore this H plus ion concentration is equal to anti-log, taking anti-log of both sides, log is removed, and we take anti-log of minus 5.4. This anti-log of minus 5.4 is equal to 3.98 into 10 to minus 6 moles per liter. And this is the final answer, that is the H plus ion concentration. To remove this log, we taking the anti-log of both sides. Anti-log of minus 5.4 is the final answer. How we calculate the anti-log? So it is explained here. Third problem, degree of ionization, that is alpha of 0.1 molar monobasic weak acid is 0.130. Calculate pH of solution and pK of monobasic weak acid. So what is the problem? They asked to calculate pH and pK of this weak acid. We know this H plus ion is equal to C into alpha. C is concentration, alpha is degree of ionization. So degree of ionization is 0.1 and this concentration is given. Degree of ionization of 0.1 molar monobasic weak acid is 0.13. So degree of ionization is 0.13 and concentration is 0.1. So C is a concentration 0.1, alpha is a degree of ionization, that is 0.13. So multiplication gives 0.013 moles per liter. So what is the 0.013 moles per liter? It is a C into alpha, that is the concentration of H plus ion. As we know the concentration of H plus ion, we calculate pH. What is pH? Minus log of H plus ion. So minus log of 0.013. So taking log on, so here we can use calculator, scientific calculator. So log is easily find out on scientific calculator. This final value is 1.886. So pH is 1.886. We arrive first. Then second is to calculate pK. So ionization constant of weak monobasic acid Ka is equal to C into alpha square upon 1 minus alpha. So we put directly values in this C and alpha. So Ka is equal to C is concentration, that is 0.1 into alpha. Alpha value is 0.13, taking it square upon 1 minus alpha, 1 minus 0.13. To square this, multiply, subtract this and taking the ratio, we get this final answer. So here is also you can use calculator. Calculator is allowed in exam also. Therefore final answer of K is equal to 0.00194. So this is the value of Ka. This is the value of Ka. What is Ka? Ka is the ionization constant of weak acid. But in example they want pK value. So what is pK? pK is equal to minus log of Ka. So this is the K value. Put this K value in this equation, minus log of 0.00194 and the final answer is 2.71. So this pK is equal to 2.71 and pH is equal to 1.886. So this is the final answer of this example. So next example, calculate the degree of ionization of 0.01 molar acetic acid if its pK value is 4.74 at 25 degrees. So pK is given, concentration is given, they want to calculate this degree of ionization, that is alpha. So we know this pK value is given. What is pK? Minus log of Ka. So log of Ka is equal to minus pK. So when we remove this log, what we take? We take this anti-log of both sides. Log is removed and taking anti-log of minus pK. So K is equal to anti-log of minus pK is equal to anti-log of minus pK is 4.74. So taking anti-log of this term, we get the final answer, that is 1.82 into 10 raised to minus 5 and this value is K value. That is the ionization constant of that acid K. So this ionization constant of acid K, we know the formula, it is equal to C into alpha square upon 1 minus alpha. We consider this ratio as C into alpha square. Why? Since this acetic acid is a weak acid, this degree of ionization is very small, negligible compared to 1. So this 1 minus alpha is equal to, or it is nearly equal to 1, and thus and hence this equation become Ka is equal to C into alpha square, and thus this alpha square is equal to Ka upon C, and thus this alpha square is equal to Ka upon C. So we have the value of Ka, we have the value of concentration C. So putting this value, this degree of ionization is, see here, this is the value of alpha square. We have to calculate degree of ionization, that is alpha. For that alpha, what we take? We take this under root of Ka upon C. So this is under root of Ka upon C. So we put this value under root of 1.82 into 10 raised to minus 5 upon concentration 0.01 molar. So solve this on calculator, taking under root of and the final answer is 0.0426, and this 0.0426 is the value of alpha, that is the degree of ionization. So next point, common ion effect. So this term we heard, you can heard from 11th standard, 11 and 12. Now again we repeat this term, common ion effect. So this word is common, ion. These ions are common, and what is the effect? See here, the dissociation or ionization of weak, see this word is very important, weak electrolyte is suppressed by addition of strong electrolyte containing one of the same ion of weak electrolyte is called as a common ion effect. So in weak electrolyte we added strong electrolyte, and both weak electrolyte and strong electrolyte must contain one of the ion is same, that is common, same or common, and this effect is given by this common ion or same ion is called as a common ion effect. So what is that effect here? If salt of weak acid is added to the solution of weak acid itself, the ionization of weak acid is suppressed. If the salt of weak acid is added to the solution of weak acid, we have the weak acid solution, this weak electrolyte, weak acid solution. In this weak acid solution we add strong electrolyte, that is the salt of weak acid, and this ionization of weak acid is suppressed, and due to this addition of strong electrolyte, that is salt of weak acid is a strong electrolyte. When we added in this salt is a strong electrolyte, when we added in acid, what happened? This acid concentration is suppressed. This weak electrolyte this ionization of weak electrolyte is suppressed. When we take this one example that is more clear, by the addition of aqueous solution of sodium acetate, so this is the salt of weak acid, acetic acid, to the aqueous solution of acetic acid, the ionization of acetic acid is suppressed and will shift to the left, and this separation left direction called as a common ion effect. See a reaction, this acetic acid is a weak acid, weak electrolyte, it ionize equilibrium, it dissociate partially, so it form acetate ion plus H plus ion. When we added in this solution strong electrolyte, that is salt, this salt is sodium acetate, this sodium acetate is strong electrolyte, dissociate completely, and in both this weak electrolyte and salt solution this acetate ion is a common ion or same ion. And due to this common ion, what happened? Solution have more concentration of acetic acid, sodium acetate, acetate concentration is more. Due to this more acetate concentration, to balance this equilibrium, this acetate ion combined with H plus and goes this reaction in left side or reverse direction to form a acetic acid, and thus this dissociation of acetic acid is suppressed, decreased by addition of this strong electrolyte. This strong electrolyte is completely provide common ion, and this equilibrium shift to the left direction, and this acetic acid, that is weak acid, dissociation is suppressed or decreased. That is the common ion effect. The addition of acetate ion supply by largely dissociated sodium acetate, this is the concentration salt, reduce or suppress the dissociation of acetic acid, so this equilibrium shift in this direction, so this ionization is decrease or suppress by shifting the equilibrium towards the reactant side. This red arrow indicate shifting to the reaction side, and it is based on the Le-Chatelier principle. So in this equilibrium, when we give the trace, in this case we added common ion, so this equilibrium is maintained by consuming this common ion with combination with H plus to form a acetic acid, and this reaction shift to the left direction, that is a Le-Chatelier's principle. So for this acid, now we consider second example for a base. Consider this weak electrolyte as a base, ammonium hydroxide. Dissociation equilibrium shows ammonium ion concentration, OH minus concentration. In this weak electrolyte, when we added salt solution, this ammonium chloride, dissociate 100% completely, provide this ammonium ion as a common ion. And due to this ammonium ion as a common ion supplied to this solution, this largely dissociated ammonium chloride salt solution reduce or suppress the dissociation of ammonium hydroxide, and by shifting equilibrium towards the reactant side, again according to the Le-Chatter's principle. So this is the equilibrium. When we added ammonium chloride, it provide large amount of hydronium ion, and this large amount of hydronium ion combined with OH minus to maintain this equilibrium shift in this left side or reverse direction, and thus this ammonium hydroxide ionization is suppressed or decreased according to Le-Chatter's principle, and this is the common ion effect. Next point is buffer solution. What is buffer? Aqueous solution which resists the pH change, in pH on addition of small amount of acid or a base is called as a buffer solution. It is used in many purposes of chemistry, biology and industries. They are of two types, acidic buffer and basic buffer. So what is acidic buffer? These are the solution which maintain the pH value less than 7. So what is this buffer? It is aqueous solution and which resists the pH change on addition of small amount of acid or base. So it maintain the pH, resists the pH, do not allow solution to change the pH by addition of, see this word is important, small amount of acid or small amount of base. This solution resists the change in pH or it maintains the pH, and that pH, depending upon that solution pH, we have two types, acidic pH. If this solution is acidic solution, there are solution which maintain the pH value less than 7. At that time such buffer solution is called as a acidic buffer. When this aqueous solution which maintain the pH value greater than 7, larger than 7, at that time this aqueous solution is called as a basic buffers. So this buffer having two types, acidic buffer and basic buffer. pH value less than 7, basic buffer pH value greater than 7. So what is acidic buffer and its mechanism? So this part we consider for the next lecture. Thank you.